We can use our unit circle to evaluate a point on that circle for any angle rotation. So a question that we see is find the point xy on the circle that corresponds to the real number t. T is equal to pi over 2. So what they're telling us is this arc length is pi over 2. So I'm going to grab my sketch, and you can draw this by hand. You don't have to draw it real neatly, but pi over 2 is right here. That angle rotation, pi over 2, and so I'll just make a little note, pi over 2 is equal to 90 degrees. Most of us are more comfortable with degree measurement than radian, at least right away. So when we get to this angle rotation where we start out here at 0 degrees and rotate around to 90 degrees, we're talking about this angle right in here, which corresponds to the arc length that is that pi over 2. Remember, that's at 1.57 approximate value. So 90 degrees and pi over 2 are the same exact thing. And of course, this ordered pair here is 0, comma, 1. And so that is our answer for the ordered pair x comma y. And so we can put that into our homework set if that was a homework question of ours. How about 5/4 pi? That's another question on there, 5/4 pi. So what I'm going to do is I'm going to count out 5/4 pi. Now, one of the things I know, now I'm just going to estimate this right here. This is 1/4 pi. I might write it just pi over 2. Pi over 2 times 1/2 is pi over 4 is what I should have said there. I'm going to write it 45 degrees is equal to pi over 4. And so what I'm going to do, I'm going to count out 5 of those. So I've got 1, 2, 3, 4, 5 of them. So 5/4 pi is right down here. And I'm going to put the ordered pair that belongs to 5/4 pi. Now, one thing that we'll recognize is this is that nice little triangle, that very convenient triangle, the isosceles right triangle. So I've drawn the little nice isosceles right triangle in here. Now, because of Pythagorean theorem, the x and y coordinate, which happens to be the same here, of course the x and y are the same, when we have an isosceles right triangle. Hypotenuse is 1 because we're dealing with the unit circle. So the ordered pair up here, and you say, wait a second, we're talking down here. So yeah, it's not a problem because this is our x, square root of 2 over 2, and this is our y. Actually, I should keep it color coordinated. Square root of 2 over 2. There we go. I was using red for the y coordinate and blue for the x coordinate in a previous video. It was kind of fun, so I'll keep doing it here. So when we look at this point over here, the x coordinate is negative. Well, the y coordinate is negative also, but we see this will be a real easy one for us. Negative square root of 2 over 2, comma, square root of 2 over 2, like so. So when we enter in the x and y coordinate for 5/4 pi, oh, hold on, negative, negative square root of 2 over 2, negative square root of 2 over 2, because this is quadrant 3. You remember quadrant 3, quadrant 2, quadrant 1, and quadrant 4. In quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. Quadrant 3, they're both negative. Quadrant 4, x is positive, y is negative. There we go. Now we'll try another one, 7/6 pi. So what we're going to do is we're going to find where 7/6 pi is. Now one of the things that I'll notice is 7/6 pi is equal to 6/6 pi plus 1/6 pi, right? And 6/6 pi is just pi. And 1/6 pi is, well, that's 30 degrees. And this is 180 degrees. So when we're locating it on our circle, 7/6 pi and 210 degrees are the same thing, but it makes it real easy to recognize where it belongs. 7/6 pi I'll come over here from 0 to 180 degrees. 180 degrees right here is pi radian. So I've made it to 1 pi, and all I have to do is add another 30 degrees to it. So I'll just do a little estimation here. About here's 30 degrees, and I'm going to map it out. So our 7, 6 pi is right in here somewhere. Alright, it was actually more like here. I kind of estimated here. I estimated the angle a little shallow. So here's 30 degrees in here. This is 30 degrees right here, 90 degrees here, 60 degrees here, and this happens to be one of those special little triangles as well. Now our hypotenuse is 1, and this y-coordinate here in the triangle, it's equal to 1/2. This is 1/2 right here, and then I'll label this other one. Let me grab my blue pen. This would be the square root of 3 over 2. There we go. So the ordered pair that we're talking about, this one belongs to the 5/4 pi. 7, 6, this ordered pair right here that corresponds to 7, 6 pi, the ordered pair would be negative square root of 3 over 2, right? And comma negative 1/2, like that. Remember, we're in quadrant 3 again at 7, 6 pi. So we do have the negative square root of 3 over 2, comma negative 1/2. All right. I think we can finish this one up.